All right, so we'll just start with problem number 1, and that is solve the given equation for x, which is 6 raised to the 2x minus x squared equals 6 to the negative 8. Okay, so all right, in this case here, we have an exponential equation that we're going to solve for x. Now notice in this case that our bases are the same. And once the bases are the same, I can set this exponent to be equal to the other exponent. So I'm going to have on the left side 2x minus x squared is equal to negative 8. So now I have a quadratic equation, which I'm going to try to get a 0 on one side of this equation. And it'd be best for me to move the minus x squared and the 2x over to the other side. So what I'm going to do is add x squared to both sides. And I'm also going to subtract 2x on both sides of this equation. So here I have a 0 on the left side. Now on the right side, I have x squared minus 2x minus 8 equal to 0. And then the next step would be to factor x squared minus 2x minus 8 into two binomials here. And x squared factors out as x times x. Now we have to think of factors of negative 8. That would give us a minus 2x as a middle term. Any ideas? Negative 4 and 2. So it'd be a minus 4 here and a plus 2 here. So it'd be x minus 4 times x plus 2 is equal to 0. And then we set each binomial factor to be equal to 0. So it'd be x plus 4 equals 0 or x minus 4 equals 0 or x plus 4 equal to x plus 2 equal to 0. And then we solve each equation for x. So for the x minus 4 equal to 0, we're going to have x to be equal to 4. And then for x plus 2 equals 0, that means x is equal to negative 2. Okay. So 4 and negative 2 are the two solutions for this exponential equation. All right. Any questions about problem number 1? All right, number 2 is this. Find the value of an investment of $20,000 for 11 years at an annual interest rate of 3.85% compounded continuously. Okay. So here's what we have. We have a $20,000 investment, that's P, for 11 years at an annual interest rate of 3.85%. And we are told that it is compounded continuously. Okay. Now, if it's compounded continuously, that means we're going to need to use this formula, A is equal to P times e to the RT. A is equal to P times e to the RT. Because the problem does say compounded continuously. So now let's do some substitution here. So here A is equal to P, which is $20,000, times E to the R, that's going to be, and by the way, what's 3.85% as a decimal? 0.0385. Now, to get that, you can just take that 3.85 and divide that by 100, since percent means per 100. You'll get the decimal, 0.0385. And then we use our calculator to get the amount. So here you'll get 20,000, and then second LN for the E, and then 0.0385 times 11. And we round this answer off to 2 decimal places since we're dealing with money amounts. So that means that this amount would be $30,545.96. Okay. That represents the value of a $20,000 investment for 11 years at 3.85% compounded continuously. Okay. Are there any questions about problem number 2? All right, number 3. Suppose that $5,700 is invested at 3.5% annual interest rate compounded monthly. How much money will be in the account for 19 years? Okay. So now it's compounded monthly, so that means we have to use that other compound interest formula. Okay, so here's what we have. Okay, we have $5,700 invested at 3.5%. And what's 3.5% as a decimal? 0.035. And it's compounded monthly, so that means, I think that we're using M in this formula. It's compounding monthly, that means that there are 12 compoundings in a year. So M would be equal to 12. And we're dealing with 19 years, so T would be your 19. So our compound interest formula that we'll be using is A is equal to P times 1 plus R divided by M. And that's raised to the M times T. So we just do our substitution here. That'll be, excuse me, the P is 5,700 times the quantity 1 plus R, that's 0.035, divided by M, that's 12, divided by M times T. That'll be to the 12 times T, which is 19. Let's see. I think we can do all of this in the calculator. If we can. So here it is. We start with 5,700, and then left parentheses, 1 plus 0.035 divided by 12, and then close parentheses, and then press the hat key for the exponent, and type in 12 times 19. Okay. So this is the amount after 19 years of a $5,000 investment at 3.5% compounded monthly after 19 years, which will be $11,072.87. Okay. All right. Are there any questions about problem number 3? All right, number 4, solve for x in the equation. So here we got log to the base b of x plus log to the base b of x minus 3 is equal to log to the base b of 40. Okay. Now on the left side, I need to condense as a single logarithm using either the product rule or the quotient rule or the power rule. Okay. So there were 3 different rules that we looked at back in section 1.6. Okay. So with the plus sign, the sum of the individual logarithms means I can condense that as the log of the product. So I can use the product rule and write this as log to the base b of x times x minus 3 is equal to log to the base b of 40. And with that, I can go ahead and use something called the one-to-one property. Since I have log to the base b on both sides, I can apply that one-to-one property by setting this expression to be equal to 40. So this x times x minus 3 would be equal to 40. And from here, we can solve this equation. If I distribute the x over the x minus 3, I would get x squared minus 3x, and that's equal to 40. So now I've got a quadratic equation where I need to get a 0 on one side. Right, so in this case here, if I subtract 40, here's where I have x squared minus 3x minus 40. That's equal to 0. Now, let's factor x squared minus 3x minus 40 into 2 binomials here. So x squared breaks up as x and x. What factors of negative 40 would give me minus 3x as a middle term?
Negative 8.
Okay, good. Negative 8 and a positive 5. So it'd be x minus 8 times x plus 5 equals 0. And then we solve, well, set each binomial factor equal to 0. So this means x minus 8 is equal to 0, or x plus 5 equals 0. And each one of these will solve for x. So for the x minus 8 equals 0, that means x is equal to 8. Or for the x plus 5 equal to 0. That means x is equal to 5. All right, now, of course, it's best to check your proposed solution. And pretty much you can try to look at it and see, will I get a log of a negative number when I replace the x with 8? In this case, I won't. But what about negative 5? I would, because I can't take the log of a negative number, and I cannot take the log of 0. So you want to exclude that value for x. So I'll exclude x equal negative 5. And I'll say that x equals 8 is the solution to that logarithmic equation. Okay. Any questions about problem number 4? All right, number 5 is another logarithmic equation. Here we got log to the base 10 of x plus 7 minus log to the base 10, x plus 7 minus log to the base 10 of x minus 7 equals to 1. Okay. All right, with this one, we have a minus sign in between the logarithms, so I need to use the quotient rule. Here, the difference of the individual logarithms can be condensed as the log of the quotient. So we have log to the base 10 of x plus 7, that goes in the numerator, divided by x minus 7, that goes in the denominator. That would be equal to 1. And then the next thing we're going to do here is write this in its equivalent exponential form. So if I write that in its equivalent exponential form, it's going to be this. My base here is the 10. This exponent, that 1 will be your exponent, and that's going to be equal to this expression right here. So in its equivalent exponential form, it will be 10 to the first power, 10 to the first, equaling to x plus 7 divided by x minus 7. And that 10 to the first power is just going to be 10. But I'll write this as 10 over 1, equaling to x plus 7 divided by x minus 7. And from that, we can just do cross multiplication. And when I do cross multiplication, this will be 10 times x minus 7, with the x minus 7 in parentheses, equaling to 1 times x plus 7, which is x plus 7. And if I distribute that 10 over the x minus 7, this will be 10x minus 70, equaling to x plus 7. and then get all the x's on one side by subtracting x. So that means 9x minus 70 is equal to 7. And if I add 70 on both sides, I'm running out of space here, so I'll continue it over here. Then 9x is equal to 77. And then finally divide both sides by 9. And I'll leave that as 77 over 9. I don't believe I can reduce that in its simplest form. Okay. And I can check to see that this will not be 0, this will not be a negative or 0. So x equals 77 over 9 would be the solution to that logarithmic equation. Okay. Are there any questions about problem 5? All right, number 6 is to solve the equation of 4 decimal places. Here you got e to the x equals 2.405. E to the x is equal to 2.405. Now, since e and the natural logarithm are inverses of each other, it would be best to go ahead and take the natural log on both sides. So that's what I would do here. And I also know this. If I have ln of e to whatever this exponent is, it's going to end up being that exponent. So ln of e to the x is x. And that's equal to ln of 2.405. And then the 4 decimal places, using the calculator, ln 2.405. And to 4 decimal places, this will be approximately equal to 0.8775. Okay. All right, questions on number 6. Okay, number 7 is solve the equation of 4 decimal places also. This will be 1.373 to the 12t equals 2. Okay. So in this case here, this too is an exponential equation because the t is in the exponent. So the only way to solve this will have to be to take the natural log on both sides. So I need to do the natural log of this left side and the natural log on the right side. Now on the left side, I can use what they call the power rule. And that power rule states I can take this exponent, bring that in front of the natural logarithm. So I'll go ahead and bring the 12t in front of the natural log of 1.373. And that's equal to the natural log of 2. And then the next step would be to get t by itself. And I'll do that by dividing both sides by 12 times the natural log of 1.373. Okay. Then you have to be careful how you enter this in the calculator. That numerator is ln of 2, so here I'm going to press the ln key and then the number 2, close parentheses. Then that's going to be divided by what's in this denominator will have to go in parentheses. Okay. So I'm going to start that denominator off with the left parentheses, 12, and then press the ln key, and then 1.373. Have to close the parentheses around the ln and then close it again for the left parentheses here that I opened. And then hit enter. And they want this answer to 4 decimal places, so this will be approximately 0.1822. So t in this case will be 0.1822. All right. Are there any questions about problem number 7? Okay. So those first 7 problems were from sections 1.5 and 1.6. So pretty much the rest of this, we're dealing with limits. All right, so in problem number 8, you're going to be given a graph of some function, and you're going to use that graph to estimate the indicated limits and the function value. Okay. So in part A, you want to find the limit as x approaches -1 from the left of f of x. The limit as x approaches -1 of f of x.
0.
It is 0. Because from the left, if you come in from the left, it's going to be 0. It's getting closer and closer to 0. So we say the limit as x approaches -1 from the left of f of x is 0. Now what about the limit as x approaches -1 from the right of f of x? Is also 0, because as we come in from the right of -1, we're getting closer and closer to 0. We're approaching 0. And what would be the limit as x approaches -1?
0.
Also 0. Okay? So no, the limit exists when we come from the left and from the right, they're going in the same value. And what about f of -1?
0.
Also 0. Okay, so from the graph, at -1, I'm going to be at 0. Okay, any questions about problem number 8 and how that's done? All right, number 9. Is to find the limit if it exists. So here we got the limit as x approaches -1 of 3x plus 10. And in this case here, this is just a linear function, so all we can do there is just do direct substitution. Directly substitute the x with that -1. So it'll be 3 times -1 plus 10. And 3 times -1 is -3. And what's -3 plus 10? Should get 7. Okay. All right, questions on problem number 9. Now number 10, the limit as x approaches -7 of x squared minus 8 divided by 7 minus x. All right, in this case here, can we use direct substitution? Yeah, because we're not going to get a 0 in the denominator. As long as we don't get 0 in the denominator, then direct substitution can be used. So I'll go ahead and replace the x, each x with -7, and that's squared. So -7 squared would be 49 minus 8 divided by, what's 7 minus -7? 14. 49 minus 8 would be 41, and that'd be 41 over 14. And you can leave it as an improper fraction. Okay. Any questions about problem number 10? All right, number 11. In number 11, we're given that the limit as x approaches 2 of f of x equals -6, and the limit as x approaches 2 of g of x is equal to 5. Here we're going to find the limit as x approaches 2 of 2 f of x plus g of x. All right, in this case, we're going to have to use some of those limit laws before we start figuring this out. Here I got the limit of a sum. I can write that as the sum of their individual limits. So I can write this as a limit as x approaches 2 of 2 times f of x, and then plus the limit as x approaches 2 of g of x. And that constant of a 2 times f of x, that 2 can go out in front. So it'll be 2 times the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. So in this case here, if I know that the limit as x approaches 2 of f of x is -6, here's what I have. 2 times -6 plus the limit as x approaches 2 of g of x, that's going to be 5. That's given to us. So now 2 times -6 is -12, and what's -12 plus 5? -7. Okay. Are there any questions about number 11? In number 12, they have this. For the function f of x is equal to negative 9x minus 9 divided by x minus 9 and the quantities to the fourth power, we want to find the following. We want to find the limit as x approaches 9 from the left, the limit as x approaches 9 from the right, and the limit as x approaches 9 for that function. Use negative infinity or infinity where appropriate. Sometimes it does help to use the graphing calculator just to get a visual representation of this. And here I'm going to go under y equal to, and under y1, I'm going to type in the negative key. And I'm going to put that 9x minus 9 in parentheses. So it'll be negative and then left parentheses, 9, xt theta n for the x, minus 9, close parentheses. And then that's divided by, the denominator will be in parentheses also, so left parentheses, xt theta n for the x, minus 9. Close parentheses, and then to the fourth, we press the hat key and then the number 4. And I would do zoom 6 for the standard window. Okay. Or better yet, zoom fit. Sometimes you got to play around with this calculator to get the graph that you want. No. Or better yet, do a window. No. Let's do a window. Because we're dealing with 9 here, so let's see here. I'm going to start my x-min at 0, and then do 15 in increments of 3. Y-max will be, my min will be 0, Y-max will be 10. Sometimes you got to play around with this to get the graph that you want. Okay, it's the other part right here. The window. I'm going to do from 0 to 10. Okay. But let's look at this anyway. If I let x approach 9 from the left, 4, 5, 6, 7, 8. Here's 9 from the left. Where do you think this is going off to? Negative infinity. Okay. So we know. So I know one thing. The limit as x approaches 9 from the left of the function f of x. That's negative infinity. All right, so that's part A. Okay, there we go. There's the other one. Now, I went from 0 to 15 in increments of 1 on the x, negative 10 to 10 on the y. Now, for part B, the limit as x approaches 9 from the right of that function. So where do you think this is going off to? Also negative infinity. And then the limit as x approaches 9 of f of x. Where would that go to? Also negative infinity, because both sides are going to negative infinity, so that means the limit as x approaches 9 of the function f of x goes off to infinity. Okay. Are there any questions about problem number 12? Okay. All right, number 13. For the polynomial p of x equals 14 plus 4x is 6 minus 7x is 7, we want to find the following, and that is the leading term. So here we got p of x is equal to 14 plus 4x to the 6 minus 7x to the 7th. Okay? Now, before we can find out what that leading term is going to be, we need to put this in descending powers from the highest exponent to the constant term. So that means p of x is equal to this. Here's the highest exponent, which is 7. So that term is negative 7x to the 7th, and then plus 4x to the 6th, and then the constant is your plus 14. So now from that we can find out what that leading term is. So what would be the leading term in this case? Negative 7x to the 7th. Okay. That's the leading term in that polynomial. And then part B, finding the limit as x approaches p of x. As x approaches, the limit of p of x as x approaches infinity. So limit as x approaches infinity of p of x. That's, of course, the limit as x approaches infinity. And I'm using the leading term, negative 7x to the 7th. So where do you think this is going to go off to? Just infinity? It'd be negative infinity, because of the negative in front of that 7. Yeah. Because if it was just x to the 7 and it went to infinity, it would go to infinity. But now you have the negative 7 in front, so it would be negative infinity. Okay. Any other questions about part B? In part C is the limit of p of x as x approaches negative infinity. So it'd be negative infinity of p of x. So we're finding the limit as x approaches negative infinity of negative 7x to the 7th. Now, if it was just x to the 7th, as we let x approach negative infinity, it would go to negative infinity. But here, we got negative 7x, so it would go to positive infinity. And also, if I was to do this on the calculator, But you can pretty much see here is going to be up to infinity. Are there any questions about number 13? Yes.
So if the exponent was 6, would C be negative infinity also?
Yeah, because of the negative 7.
So you just remove the leading
Mm-hmm.
term.
Yeah. All right. Any other questions about problem number 13? Okay, problem number 14. For the function f of x equal to 4x plus 9 divided by 7x minus 7, we're going to find each function value and limit use negative infinity or infinity where appropriate. In part A, we got f of 10, then f of 100, and then the limit as x approaches negative infinity of f of x. Okay. And of course, f of x was 4x plus 9 divided by 7x minus 7. And we're going to find out what f of 10 is by just replacing the x with 10. All right. Now in this case here, 4 times 10, that would be 40, plus 9 would be 49. 7 times 10 is 70, minus 7 is 63. Now I think we can reduce 49 over 63. 7, 7 over 7 over 9. Okay. So f of 10 would be 7 over 9. Okay. All right. Questions on part A. And then part B, f of 100. So here, f of 100, again, replace each x with 100, so it'll be 4 times 100 plus 9, divided by 7 times 100 minus 9. So 4 times 100, that's 400 plus 9. It's 409. 7 times 100 is 700 minus 9 will be, I think, what, 691? And if I try to do 409,
Would that be 693?
you're right, 693. I'm going to see if I can try to reduce this, but no. It's going to be 409 over 63 is the final answer. Okay. All right, questions on part B. Now, part C is when you take the limit as x approaches infinity of the function f of x. So here we're trying to find the limit as x approaches infinity of that 4x plus 9 divided by 7x minus 7. So what's going to happen here is this. I would divide every single term by the variable with the highest exponent in the denominator. The denominator does have an x in it, and its highest exponent is 1. So I have to divide every single term by x in the numerator and in the denominator. And we get 8 from the denominator. Will divide that by each term by x as well. And then I'll have a limit as x approaches infinity. Well, 4x divided by x will be 4 plus 9 over x divided by 7x divided by x, that's 7. And then that's minus 7 over x. And what's going to happen here is as we let x approach infinity, then 9 over x and 7 over x will be going to 0. Both of these will go to 0 as you let x approach infinity. So that means you're going to be left with just 4 over 7. And that would be the limit as x approaches infinity of that function, 4x plus 9 divided by 7x minus 7. All right, are there any questions about number 14? All right, number 15. Is finding the horizontal and vertical asymptotes, if any, for the function f of x is equal to 2x squared plus 3x minus 9 plus 3x minus 9 divided by x squared plus 2x minus 15. All right, so let's start with the horizontal asymptote. And I'm going to identify two things, your m and n. M is the highest exponent in the numerator, which is what? 2. The highest exponent in the denominator, which is your n, is what?
2.
Also 2. Is m less than, equal to, or greater than n? Equal to. So from that, we can look at just our leading coefficients here. That's 2 divided by 1, which is what? 2. So the equation of the line of the horizontal asymptote would be y is equal to 2. Okay. All right, questions on, well, just the horizontal asymptote. Now for the vertical asymptote. For the vertical asymptote, I'll take that denominator of x squared plus 2x minus 15, set that equal to 0. Now, I was wondering if we could factor out that, if we can simplify this a little bit. Okay. I'm gonna try something here. And x. Let's say 3 and 3. Yeah, I can. Because I know something else here. Because you want to make sure that this is divided out. This has no common factors in them before you can identify your vertical asymptotes. Okay. So I can see that numerator, and I'm using trial and error method here. This will be 2x minus 3 times x plus 3. The denominator, I have an x and an x. Factors of minus 15, that would give me plus 2x, would be a, let's say, a plus 5 and a minus 3. Okay. I thought I did, but that's not the case here. So here there are no common factors to divide out. So I just want to make sure that I have no common factors in them. If I do, I need to divide those out and then identify my vertical asymptotes. So now, I'm just set x plus 5 times x minus 3 to be equal to 0. And then set each factor equal to 0. So it'll be x plus 5 equal to 0, x minus 3 equal to 0. So here if I subtract 5, you'll get x is equal to negative 5. And then for the x minus 3 equals 0, that'd be x is equal to 3. So here I have two vertical asymptotes. One will be at x equal negative 5. The other one will be at x is equal to 3. Okay. Are there any questions about problem number 15?
I'm a little confused on what the 2x minus 3, x plus 3, where that came from.
Oh, I just, the way I did this was just, I know 2x squared can only break up as 2x and x. And I use factors of 9, would be something like 3 and 3. And I had to put the plus 3 here and the minus 3 here. That way, 2x and 3 would give me 6x, minus the 3x would give me the middle term of 3x. Okay. I had to use trial and error on that numerator because I want to make sure that I have no common factors in the numerator and in the denominator that I need to divide out. And in this case, okay, I don't. All right, any other questions about problem number 15? All right, number 16 is to use the graph We're going to use this graph of the function to estimate the indicated quantities to the nearest integer. So in part A, we have the limit as x approaches negative 3 from the left of f of x. All right. So here in this graph, we need to find -3. So here, -1, -2, -3 is over here. As we come in from the left of -3, where is this? The graph is getting closer and closer to what value? -2. So the limit as x approaches -3 from the left of f of x, that'll be -2. Part B, the limit as x approaches -3 from the right of f of x. So as we come in from the right of -3, the graph is getting closer and closer to what y value? Also -2. And then part C. The limit as x approaches -3 of f of x. That would be what? -2. Okay. Now part D is what is f of 3? So what will be the value or the y value for that point when it's at -3?
That's supposed to be -2 then?
Yeah, that's -3 as well. Mm-hmm.
It says f of 3.
Yeah, f of 3 is.
So that'd be -1.
Mm-mm.
3, but that's
Okay, here's -3 right here. Here's that point.
No, I understand. So the question says D is f of 3, not negative.
Oh, f of 3. Why do you say that? Okay, I'm sorry. And I think I miscopied that. That should say f of -3. Okay, I need to correct that. So f of -3. But what's f of -3? -3. Okay. Yeah, that's a mistake on my part. And then part E. At x equals -3, is that function continuous? It's not.
How do you tell this, just so I know? Usually how do you tell this?
There are like 3 different rules for continuity. And it is, I think,
It's just, like, is there a way you can, like, just, like, check out the graph and see, or is it like, just look at numbers? Like,
well, by looking at this, I can tell it's not continuous because there's a hole in the graph at,
oh, I see.
yeah.
Okay.
All right. Are there any other questions? Okay, that was number 16. Number 17 is determine whether each function is continuous and use interval notation. So in number 17, you have f of x is equal to 5x minus 2. And I need the intervals on where it's continuous. What was that?
All real numbers?
All real numbers. Right. Because this is a linear function. Any x value that you assign to it, you're always going to get an f of x value for it. So from -infinity to infinity, the graph of this function is continuous. Okay, so that's part A. Part B, g of x is equal to x minus 1 divided by 9x squared minus 64. And oh, do we have a rational function here? So that means I need to set that denominator, 9x squared minus 64, to be equal to 0. And you know what I'm going to do? Just go ahead and solve this equation for x. So that means I'm going to add 64 to both sides. So that means 9x squared equals 64. Divide both sides by 9. X squared is equal to, I'll leave this as 64 divided by 9. But when I take the square root on both sides, I include the plus or minus. So that means x is equal to plus or minus, what's the square root of 64? 3. 64 is 8. Square root of 9 is 3. So I know at negative 8/3 and positive 8/3, I would get a 0 in the denominator. So if I want the interval notation for that, say negative 8/3 is here, positive 8/3 is here, okay. Any x value less than 8/3, less than negative 8/3 would work. Any x value in between negative 8/3 and positive 8/3 would. Any x value greater than 8/3 would. So here's the interval where it's continuous on. From negative infinity up to negative 8/3, or from negative 8/3 to 8/3, or 8/3 to infinity. Okay. All right, questions about part B? And finally, part C. I'll continue this on a new page. Here we got h of x equals to the square root of x minus 2. Now here we got a radical function, so we need to take what's underneath that radical, x minus 2, set it to be greater than or equal to 0. And then to get x by itself, we add 2. That means x is greater than or equal to 2. All right, so now we know any x value greater than or equal to 2 would make it continuous. So from 2 on to the right of 2 works. So this function, h of x, is continuous on the interval 2 to infinity. Okay. Any questions about problem 17? Or does anybody have any questions regarding what will be on your first exam?